All right, so this lesson's about solving trig equations. And we've got this problem, given sine theta equals 2/3, find possible values for cosine theta exactly. So first of all, when I say sine theta equals 2/3, what I really mean is y over r equals 2/3. And therefore, there are two possible scenarios where I can do that. So I'm going to draw two circles. And in order for y over r to be positive 2/3, since the radius is always positive, that means y has to be positive. So I have to either go into the first quadrant or into the second quadrant. And maybe I can make my right triangles from that. Going back to the x-axis always, of course. And now I can start labeling things. So the y would have to be 2 and the r would have to be 3 in either scenario. Now that's not actually true. We could have 4 and 6 or 20 and 30. It doesn't really matter. Any multiples of 2 and 3 would be fine. But the convenient one is just 2 and 3. And then we can label that this angle, for example, would be theta, or this angle would be theta. And what we're looking for is cosine theta, which means we need x over r. Well, that means we need to work out what x is in each of these scenarios. So we can use Pythagorean theorem. So we basically say x squared plus 2 squared equals 3 squared. So basically we're saying x squared equals 5 if I do subtraction, right? So 9 minus 4 is 5. So x equals plus or minus root 5. And both of those are okay because this is the positive root 5 scenario. This is the negative root 5 scenario. So let's label that root 5, negative root 5. And therefore, to get cosine theta, we say cosine theta is equal to, I'm just going to write it in one step. It's x over r, which is plus or minus root 5 over 3. So those are the two scenarios that occur. Okay, so now we have tan theta equals -2, and then we're given that 3 pi over 2 is less than theta, which is less than 2 pi, and we're looking for sine theta and secant theta exactly. So first of all, when I say tan theta equals -2, let me call that -2 over 1, for example. Well, that's the y over x. Now I'm told that 3 pi over 2 is less than theta, less than 2 pi. Well, first of all, let me draw a circle, and let's figure out where that would be. Well, 3 pi over 2 is an angle that's 3 right angles, and then 2 pi, of course, is a complete circle. So we're stuck in the fourth quadrant, so the angle has to go in there, and the angle theta must have gone around like that. Now, when we say y over x equals -2 over 1, either y is negative and x is positive, or y is positive and x is negative. But if we're going to go into the fourth quadrant, it's the y that's going to have to be negative. So -2 over there and 1 over there. And now I can use Pythagorean theorem, 1 squared plus -2 squared equals r squared, to end with r squared equals 5. And here we have just r equals positive root 5 because r is a radius, so it can't be negative. So now we're asked to find sine theta, which is supposed to be y over r. Well, that's -2 over root 5, which you can actually leave that way. But if you want to write it as -2 root 5 over 5, that's okay. Now, to do secant theta, I'm first going to find cosine theta. So cosine theta is supposed to be x over r, which in this case is 1 over root 5. I'm not going to try to rationalize that because when I do secant theta equals the reciprocal, that's root 5 over 1, which is just root 5, and the numerator is, the denominator is automatically rationalized there, so I'm perfectly happy with the root 5. Okay, so now we're asked to solve for sine theta plus 3 is equal to 0, for 0 less than or equal to theta less than or equal to 360. So here we're looking for the angle. So the first thing I'm going to do is I'm going to isolate sine theta. So I'm going to say sine theta equals -3/4. And now I go to my thought bubble and I say, well, that just means y over r equals -3/4. And there's two possible places where I can do that. So here are the two circles. Well, y over r is -3/4. R is always positive, so y is going to have to be negative. So either I go like this, and I get a -3 and a 4, or I go like this. So third quadrant or fourth quadrant, I get a -3 and a 4. Now, it totally does not matter what x is. We're going to ignore that entirely. But we're now going to use sine inverse of -3/4 on the calculator. And we're going to do it in degrees mode. And I get negative 48.5903, let's say. I'm going to keep a significant number of decimals there. Well, the negative 48.59, whatever, that must be this angle here. So that's right here, negative 48.5903, etc. Now, what I need from that is the reference angle, which of course is just positive 48.5903. And that way I can find this angle by adding 180 plus that 48.5903. So this angle is 228.5903 degrees. And now the problem with this first angle that I was given is it doesn't fit within my 0 to 360 that I was told. So I now have to find an angle that goes around like that. So that's 360 minus the 48.5903. So that ends up being 311.4097. Now, there were no instructions about rounding, so I have to round to 3 sig figs. That's the default. So we have theta equals 229 degrees, or theta equals 311 degrees. So those are the two solutions for that one. Now we're asked to solve 2 secant theta plus 3 is equal to 0 for 0 less than or equal to theta less than or equal to 2 pi. Okay, so this is a radians problem. Let's first isolate the secant theta. So secant theta equals negative 3/2. And then I really don't want to work with secant theta, so cosine theta is equal to negative 2/3. And now I go to my thought bubbles. And again, we're saying x over r equals negative 2/3. So that means that we're drawing angles in either of the quadrants where x is negative. So that means that going to the second quadrant to get the negative 2 and the 3, or we're going to the third quadrant to get the negative 2 and the 3. And again, to find one of those angles, I'm going to do cosine inverse of negative 2/3. But before I do that, make sure I put it in radians mode. And I get 2.3005239, etc. So that must be, since pi is 3.14, 2.300, that sounds like this angle is 2.3005239, let's say, approximately, ... Now, that is definitely not going to give us a reference angle directly, but I can use this angle over here is the reference angle. So pi minus the 2.3005239 is going to be the reference angle. So I get a reference angle of about 0.84100, 06867, let's say. And if that reference angle is in this triangle, then it's the same reference angle over here, same exact reference angle. So now I need to find the standard position angle. Well, this standard position angle is already the 2.30 whatever. This standard position angle is going to be pi plus that 0.841 reference angle, which gives me about 3.98266. 13, let's say. And it goes on. And therefore, the angles that we're looking for, theta equals, well, that's 2.30 if I round to 3 sig figs, or 3.98 if I round to 3 sig figs. So again, the cosine inverse or sine inverse or tangent inverse or whatever buttons on the calculator can get you one of the angles. It won't necessarily get you one angle you want, and it definitely won't always give you the reference angle. So you use that and the information that you know about where the angles have to sit to find the reference angle, and then use that same reference angle in the second problem, and then make sure you're answering your question within the domain of what it was asking for, and then of course round to the 3 sig figs or whatever the instructions happen to be to answer the question. And that's the end of the lesson.